Let's go through Leak 444 sequence reconstruction. So it gives us a list of list sequences. So those kind of sequences, it is some kind of for each list, it represents some kind of dependencies. For example, one is going the two is depend on one, right? And also one goes to three, right? So if we have graph, that means one is the key, right? And it has child two and three. And it asks whether the num is the shortest super sequence of this sequence. So what is the shortest super sequence? It need to have two conditions. One is this sequence need to unique. For example, one, two, three. We have two choices, right? This super sequence can be one, two, or three. Another is the one, two, three, or two, right? So this one is not a unique result, so it will return false. And the second one, second example, one, two, right? There is some actual one here. So apparently this is not shortest. The third one, we have, for example, one goes to two, and one goes to three, and two goes to three. And so the nums is the only super sequences, and also the shortest, right? So we return true. Right. So for this the question, we'll see the sequences, every sequence list, it's some kind of dependencies, right? So for the dependencies, what we're thinking about is this kind of questions we can do topological sorting. But for this kind of question, topological sorting, we want the sequence to be unique. That means we can only have one result. So how to guarantee unique is that um, so how is that in any case, right? The size in the queue should be one, right? It cannot be more than one. If we have more than one, that means we can have multiple ways to get the super sequences. Another is that when we get the element from the queue, right, and form the super sequence, the result should be the same as the nums. No, um, should be the same, right? So. So, I think, of course, we should check, for example, we can use the index, right? So every time we get out of the elements from this kind of topologic sorting from the queue, right? We need to make sure it coming out the same as that one in the nums. And also the nums when we finish the right, so we should have the there's no extra, right? So we can use the index and in the end return index equal to n, right? So let's write code for this. Mm, so first thing we need to compose graph, and you say that this number is from 1 to n inclusive, right? So we can int n equals nums dot length. So we can do this, use this one, this integer, this one as graph, equals new um list n plus one, okay. And we can also have integrate, use array equals new int n plus one, right? So what we do is that for every list of integer, which is the sequence in sequences. So it says that this sequence actually you'll see the sequence length. It's not necessary just the length too, right? So that means we need to go through this kind of list to let's see, for every I minus one and I, right? There is this will be the parent, this will be the child, and we have this child should at degree one, right? So what we do is that we're going to for int I equals one, I smaller than sequence dot size and I plus plus. Then we're going to have let's have int mm, u and v, right? U equals sequence dot get I minus one, and v equals sequence get I. Okay. So let's say um so graph um we can do this arrays set all, right? Graph k goes to new array list. So we can have um graph u hat way, and also we are going to have in degrees v should always increase by one, right? Then what we need is um so we check those kind of integer equals to one, right? In q integer integer equals to zero and put that into q, right? New array like so for int I equals one, so make sure this is from one, right? I smaller equal to n, I plus plus. So let's say if in degree I equals zero, then we're going to in Q, right? Q offer. So let's we need to make sure we coming out of the queue, the order and the num we should fit meet with the nums, right? So what do we do? We can use the index, int index equals zero. So well, right, while this queue is not empty. So you're going to have mm, we need to make sure the size, right? So if q dot size is um, greater than one, right? Or than equal to one, we just return false. And int parent equals q not four. And what we need is so we'll say if this nums index uh we can plus plus, right? Doesn't equal to current. We just return false. And then mm, for every int next in graph current, right? We are going to have a in degree next should decrease, right? So let's say if in degrees next equals to zero, then we're going to have Q offer next, right? So in the end, we just need to return index equals n. So doing like this, we'll say assume the length of nums it is n, and if we have m elements in the sequences, so we'll say because for this one it is an m operation, right? Because we need to iterate all of the elements in the in this. So there is um and also every element they need to enqueue once, right? So this is the ON operation, right? So the time complexity will ON plus M. And the space, that same thing, right? So this is OM and as for the Q and this integer array is the ON, right? So space is also M plus M operation. And let's write a Python code for this. Let's have n equals length of nums. So let's create a graph equals this one, for underscore in range and plus one. Okay. And we have in degree equals this one multiplied by n plus one, right? So then for sequence in sequences, so we are going to have mm, so let's have for I in range from 1 to length sequence, right? So we'll have u v equals to sequence I minus 1 and sequence I. So we're going to have a graph for U append V and in degree V should pass equal to 1. Right? Then we need to have a Q equals DQ. Then we are going to for I in range and from 1 to n plus 1 because there is no zero in it, right? So if in degrees I equals 0, then we have Q append I. Then we're going to have index equals to 0. So while this Q is not empty, we are going to have if length of Q is greater than 1, of course, we need to return false, right? And then we'll have current equals Q dot pop left. So we also need to check the orders if nums 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 index doesn't equal to current. We also need to return false. Don't forget to have index the plus equal to 1. And then we'll have for neighbor in graph current. So we're going to have in degrees neighbor to decrease by 1, right? And we'll say if in degrees neighbor equals 0, then we'll have Q the append neighbor. So in the end, we need to make sure there is no actual. So we just need to return index cosine, right?